Enterprise AI changes the risk equation. We are no longer managing only infrastructure and applications. We are also managing prompts, models, data sources, outputs, agents, and vendors. In this module, we'll build a practical map for spotting AI risks early and governing them across the lifecycle. So far, we've explored how AI changes enterprise systems, where adoption creates hidden risk, and how governance creates accountability. Now we turn that foundation into risk insight, preparing for threat modeling, ethical controls, and incident response. Traditional software risk is often tied to fixed logic, known inputs, and repeatable workflows. When the same conditions occur, we expect the same result. AI-enabled systems behave differently. Their outputs depend on training data, context, prompts, and user interaction. They can sound confident while being wrong or biased, and their risk can change after deployment through drift, misuse, or new situations. Controls therefore need to cover both design and live behavior. Enterprise AI risk works more like a system than a checklist. A technical failure, such as prompt injection or hallucination, can quickly become an operational disruption. That disruption may create unfair outcomes, trigger regulatory exposure, or damage customer trust. Risk ownership cannot sit with one team alone. Security, legal, compliance, product, operations, and business leaders all need a shared model. The key question is not only what can go wrong, it is where will the impact spread? AI risk is not confined to the model. It moves through every connection in the architecture. A malicious prompt can leak data or override instructions. Retrieval sources and vector stores can introduce poisoned, outdated, or unauthorized content. Tools and APIs can turn a bad answer into a real action. Agents amplify this because they plan, call systems, and operate with permissions. Effective governance treats each component as a control point instead of trusting the pipeline by default. 3 common AI risks show why confident output is not the same as reliable output. A hallucination is a plausible answer that is false or unsupported. Bias means outcomes may unfairly advantage or harm groups. Explainability gaps appear when people cannot tell why a decision was made, weakening trust, oversight, compliance, and accountability. In AI systems, security risk can arrive as ordinary language. A prompt, uploaded document, API response, or retrieved passage may contain instructions the model treats as commands. Those instructions can override safeguards, expose confidential data, or steer outputs in dangerous ways. The key mindset is simple. Treat every input as a potential attack surface. An AI system is also a supply chain, not just a model. Bad or unverified data can poison training and create hidden failures. Retrieval adds another path, where outdated, restricted, or manipulated sources may be pulled into confident answers. Third-party models, plugins, APIs, embeddings, and platforms expand the attack surface even further. Governance means proving provenance, validating inputs, controlling access, monitoring behavior, and requiring vendor assurance when outside components influence enterprise decisions or compliance. Agent risk grows as the system moves from advice to action. A chatbot with limited tools may be manageable. An agent that can retrieve data, choose tools, call APIs, spend money, or change records needs much tighter control. The danger is not only bad answers. It is unauthorized execution, data leakage, policy bypass, or repeated mistakes at machine speed. Governance must scale with autonomy through approvals, limits, logging, escalation paths, and a real kill switch. AI failure becomes serious when model behavior turns into enterprise impact. A hallucination can mislead a customer. Biased output can trigger discrimination claims. Data leakage can become a privacy incident. Automation errors can disrupt operations and revenue. Accountability matters here. Legal, compliance, operations, security, procurement, and business owners all have a role. Even when AI comes from a vendor, the consequences still land with the enterprise. An AI risk register turns vague concerns into governed work items. Each risk is recorded with the affected system, lifecycle stage, owner, likelihood, impact, and existing controls. For AI, add fields such as model type, data sensitivity, autonomy level, explainability needs, and human oversight. The real value is traceability. Every risk links back to policies, regulations, test evidence, and incidents, so compliance, security, legal, governance, and business teams can review it and drive remediation. Likelihood times impact is still a useful starting point, but AI needs a richer score. Ask what the system can do on its own, what data it touches, who is exposed, whether outcomes can be reversed, and whether laws or weak controls raise the stakes. The score is not just a label. It determines review depth, approval level, testing, monitoring, and escalation across the portfolio. High scores should automatically trigger stronger governance and executive visibility. As AI capabilities move into SaaS tools, APIs, plugins, and external datasets, outsourcing the technology does not outsource the risk. Treat every vendor as part of your AI control environment. Ask how the model behaves, how data is stored or reused, what security controls exist, and what evidence proves compliance. Then lock expectations into contracts, including retention, training use, breach notice, IP, liability, and audit rights. The rule is simple. Third-party AI risk remains enterprise risk. AI incidents are not all handled the same way. Start by naming the failure pattern, such as hallucination, unsafe output, leakage, bias, poisoning, or agent misuse. Then rate severity by real impact: business disruption, affected users, sensitive data, regulatory exposure, and whether harm can be reversed. Finally, assign clear ownership across security, governance, legal, compliance, engineering, and business teams. Classification turns confusion into prioritization, so the right response can happen quickly. AI risk management starts with visibility. That means understanding technical, ethical, operational, legal, and business impacts, and knowing where risks appear across prompts, data, models, vendors, and agents. From there, reusable patterns help score, evaluate, control, and classify risk. Next, we turn that visibility into structured AI threat modeling.